morning to all of you. I'd like to welcome you to our workshop on traffic signing for supervisors. My name is Mike Fitch. I'm with the LTAP Center. How many of you have been to an LTAP workshop before? Anybody? About half? Okay. I'll just give you a brief overview of what the center is about before we get started this morning. Our center is sponsored jointly by the Ohio Department of Transportation and the Federal Highway Administration. And what we do is transfer technology and information by way of workshops and through a newsletter that we publish every 3 months. Those of you who are not familiar with this newsletter, I'm going to have copies of this available at the registration table. You're welcome to pick up a copy, and if you'd like to get on the mailing list, that is free, and there's an 800 number on the back that you can call to receive the newsletter. Also on the registration table, there will be some publications as examples of what we have available through the T2 Center. We have a video library with more than 500 titles of videotapes on different training topics, everything from pavement management to signing to OSHA safety. You can borrow up to 3 videotapes at a time for free, so we have catalogs out on the registration table at the break for that. We also have a publications library where you can pick up a variety of publications in different traffic and safety topics as well. So those will all be on the registration table. Anyone who did not pick up a name tag and sign in. Reminder to our speakers, we're going to try to keep very tightly to our schedule this morning because after lunch we're going to be heading out to the do the plant tour. So please, for speakers, keep tightly to the schedule. I was going to leave this little clock up here as a not so subtle reminder to the speakers, but the battery's slow, so this thing's running slow. That wouldn't do us any good. So I'm going to take the clock, but either myself or Chuck will give you a nudge if you're running over time. With that, I'd like to go ahead and introduce Chuck Kleiner. Chuck is a traffic engineer for how many years with ODOT?
27.
27 years with ODOT. Previous to that, he worked 6 years in Abilene, Texas as a traffic engineer, and he will be your main host for today. So Chuck Kleiner.
It's nice to see all of you here. This workshop, we have tried to put together an assortment of speakers who represent a broad spectrum of the materials industries. And on the table in front, we have some materials that you may want to look at. They're free for you to see what they are. They are applicable in many traffic control ideas. The Manual of Traffic Control Devices is a big green book. There's also a couple of the older copies of the manual. There's a copy of the 1963 edition and the 56 edition there also. Our first speaker is going to talk about the latest revision to the manual and the current status of that. Traffic Control Application Standards Manual, which is a book that ODOT puts out, adding to the requirements of the manual for ODOT use. There's a traffic control in construction and maintenance operations. We don't have a copy of that. What that book consists of is actually part 7 of the Green Book. It's published separately and made a part of every contract. Construction and material specification, we don't have a copy of that. We have a copy of the standard sign design manual and the location design manual, some standard construction drawing sheets, traffic control devices. And in the sign design manual is this type of thing, the information on how to put together a sign, proper dimensions and everything, spacing. These publications are all available from ODOT as you need them if you manufacture signs. Also from the Ohio Department of Highway Safety, one other important publication for working in traffic is the Booklet of Ohio Motor Vehicle Laws. And I'd like to show a few slides really quickly to show why I think that Traffic control devices are very important. If you'd like to stretch your imagination a little bit this morning, if you have a field of grass like this, what is it? What can we use it for? Well, we can make it a park, or a lawn, or a pasture, or play games on it. What kind of games can we play on a field like this? Well, we could play baseball, or soccer, or golf. It's flat for a golf course, but in Bowling Green, that's where they are. We could play football on it. Can we play football on a field like this? How many of you have? Probably most of us. But if it's an important game, that's not enough. You need some lines and markers and goalposts to outline the boundaries and tell you where you are. Now let's look at a piece of pavement. What can we do with a piece of pavement? What makes one piece of pavement different than another? We can make a basketball court out of it, tennis court, parking lot, airport runway, or a street or a highway. It's all the same kind of pavement, but its use is different. And the difference is the traffic control devices. A piece of pavement like this provides a good smooth surface to ride on, but it doesn't do an adequate job unless it has the lines and markings and so forth to tell people how to use it. How much do we need? It depends on the situation. On a residential street such as this, the curbs and the borders may be all the guidance that's needed. But when you're on a major street like this, you need all kinds of traffic control devices. Here we've got signs, signals, curbs, pavement markings, left turn lane. We may have drivers that don't pay attention to what they're doing too. Or some think they own the road when they get behind the wheel of a car. It's come a long time since we had to follow the ruts to get where we wanted to go. Drivers now expect to have a good facility. And they have it well marked with guidance, and most drivers don't even start out with a map when they go. And they will drive a lot by habit. Habits are an important part of what we're dealing with. When we're dealing in traffic control devices, we're in the communications business. We need to communicate with a motorist, tell him what the situation is and what he needs to do. And most motorists don't look at the signs when they're in a familiar territory. When you go to work every day, you probably don't see half of the traffic control devices you pass because you don't need them. But when you're in a strange territory, they're very important and critical. Habits is very important, and it's very hard when you're working in something to see it like a stranger does. And we need to be conscious of that. When we violate the driver's expectancy, then we have all kinds of problems. And that's all of those slides that I'll show for now. How good a job is good enough? One thing I ran across not too long ago, if 99.9% is good enough, then all these kind of things would happen. With that other 1/10 of 1%. 2.5 million books would be shipped with the wrong coverage. 18,000 pieces of mail mishandled every hour. You've got a copy of that in your folder, so think about that when you think of the quality of the work you do. It's very important. And I think that's enough time for me to talk up here. I'd like to move on to our next speaker. I'd like to move on to our next speaker. We have several people with us today that are very informed on what's going on currently in the industry. We'd like to start off with the speaker from ODOT, Scott Rader. Is the assistant signing engineer with ODOT, and he's been with ODOT for about 10 years and worked a number of years in the standard section, which is the section that develops the manual and keeps it up to date, and that's a never-ending job. And for the last year, he's been in the traffic signing section. He's a graduate of Ohio State University, and without further ado, I'll present Scott Rader, who will talk update of the manual on uniform traffic control devices. Incidentally, while he's coming up, on the table up here are a few signs, some reflective material, different brands. The signs were furnished by Signs and Blanks. Oh, one other thing. The traffic seminar 2 weeks from today, the other signing for supervisors workshop, which will be in Chillicothe. The flyers that went out on that originally said that the tour would be Marion Steel in the afternoon, and that was incorrect. The tour will be at Rocal, which is a sign manufacturing facility in Frankfort, Ohio. So if you know of somebody that's interested in that, pass that information on to them. Scott Rader.
First of all, I'd like to thank T-Squared, Chuck, and Mike for giving me the invitation to speak here today. And looking over the agenda, it looks very interesting to me. I know I'm looking forward to hearing from some of the speakers, and especially touring Marion Steel later this afternoon. I'd prefer to take questions at the end of my talk here. As you know, my topic is OMUTCD update. I'll briefly explain some general items pertaining to the High Manual of Traffic Control Devices that I believe are important and that you should be aware of in case you already aren't aware of them. After that, I'll explain some of the updates that were recently made to the Ohio Manual. In the signing section, the last revision, Revision 20, which was issued in January, I believe contained revisions to other sections of the manual, but because this is a signing thing today, I'm going to limit it to signing items only. And then at the very end, I'll try to tell you what I believe Revision 21 is going to consist of. As you all are probably aware, the green manual there on the table, I hope you all can see it, is the Ohio Manual of Uniform Traffic Control Devices. That particular edition there is the 6th edition that's come about. That particular edition, again the 6th one, came about in 1972. The first edition was issued, I believe, in 1924. That came about, I believe, well before, I think at least 10 or 12 years before the federal manual ever came about. And I believe we may have been the first state, and I may be wrong, but I think we might have been the first state to come up with a manual. Since that particular edition was distributed in 1972, there have been 20 revisions issued to it, or almost one a year. Again, as I mentioned a little bit ago, the last one was issued in January. Before I get too far along, is there anybody here that didn't receive Revision 20 to the Ohio Manual? Okay, it looks like most, if not all of you did. If anybody didn't, come and see me after my talk and give me your name and address, and I'll forward it on to the proper person, and they'll be sure to send you one. Probably the main reason that revisions are issued to the Ohio Manual is so that we remain in, it's called substantial conformance with the federal manual. There's a section of Ohio Revised Code, it's section 451109, that states that well, it requires ODOT to have a manual, and that manual has to be in substantial conformance with the federal manual. And while I'm talking about Ohio Revised Code sections, there's two other sections that I'd like to briefly touch on. There's 4511.10 and 4511.11, which respectively require ODOT and local authorities such as cities, villages, and townships within their respective jurisdictions to place and maintain traffic control devices that are in conformance with those shown in the manual. Appendix B of the Ohio manual, which is in the back, contains a lot of Ohio Revised Code sections that are relevant to traffic control devices. It's a pretty important appendix that you should refer to when needed. At this time, I'd like to focus solely on the signing portion of the Ohio manual. The signing chapter is the largest chapter in the Ohio manual. I counted up to, I believe, 184 out of 486 pages, or almost 40% of the manual is devoted to signing. And then when you take into account that there's other signs shown in a couple other chapters, Part 5 is the zones chapter, there's more signs in that chapter. There's a lot of additional signs shown in Part 7, the construction and maintenance operations chapter. So when you take into account those, probably half the manual is devoted to signing. The signing chapter is broken down into 4 sub-chapters. There's a standard sign section, which is real general in nature. It gets into how high the height of a sign should be placed at, the lateral clearance, how far off the road. It tells you what colors certain kinds of signs should be, what shapes they should be, and so forth. There's also a regulatory signs chapter, a warning signs chapter, and a guide signs sub-chapter, I guess is what I should call them. And then that guide signs sub-chapter is broken down into even further chapters as well. There's an introduction, a route markers section, and a conventional highways section, and then a freeway and expressway. In revision 20, the standard sign section, which as I mentioned is general in nature, gives you general information about signing. That chapter, the regulatory signs chapter and the warning signs chapter were completely replaced. So if you haven't got it around to updating your manual, you can simply remove the existing chapters that are in your manual and put the new ones in. Quite a few new signs were introduced into the regulatory and warning signs chapters, and I'll briefly touch on those in a little while. All addendum items that used to exist for those 3 chapters no longer exist. The addendum, which is found up in the front of the manual before the very first chapter, it's been a source of frustration to a lot of users. It requires the user to go in and make pen and ink changes or cut and paste certain things, and the user of the manual really never could quite be comfortable knowing that if he went into his manual and was looking at a particular section that he was up to date unless he had done that. So by introducing the 3 new chapters, standards, regulatory, and warning, we at least did away with all the addendum items that previously existed pertaining to those. And now the only addendum items that exist pertain to guide signs, and there's still quite a few addendum items outstanding that pertain to Part 7, the construction chapter. So the addendum has been whittled down quite a bit. It's still not a good thing in my opinion, but when revision 21 is issued, I believe you won't see any addendum items at all remaining. I think they'll all be incorporated into the actual pages. At this time, I'd like to briefly discuss some of the new regulatory signs that were introduced in revision 20. You all should have a handout in front of you, it's Appendix C from the Ohio manual. It's called the sign index, and I've circled the new signs that were introduced. Is there anybody here that doesn't have that in front of them? Jim Roth will try to get you a copy if anybody else who doesn't have one of those in front of them? Okay. The first one I'm just briefly going to touch on these. I'm not going to go into any great detail and read the sections to you. But the first one's on page C-1 of Appendix C, and it's the stop here to actuate signal sign. I just checked, this sign is not in the federal manual, I believe. It's in our application standards manual. which that thing may not exist too much longer. We're in the process of converting all those to policies and guidelines and so forth. So that thing may not exist too much longer. The text, which that applies to this section, which is 2L29, does indicate that you should use a stop line with that sign. Why don't we go over to page C-3. I've circled some lane use control signs. These are just additional examples that they decided to show in the manual. There's a lot of varieties of these that exist. These three in particular, these are side-mounted signs, and I believe the text that pertains to these signs says that these should be located at the intersection with a second set placed in advance of the intersection. On that same page, on page C3, down on the bottom row, the one that's coded R-37AR, that's a sign that used to be in the high manual, and at one point they took it out. I really don't know why they ever took it out. It is a sign that's shown in the federal manual, so they decided to put it back in, and it's simply an alternate to the sign that's shown beside it, the R-37R. And also on the top of the next page, the R-38R. It's simply, those are all sort of interchangeable. Those should be used on the ends of medians, islands, at underpass piers, and so forth. I've circled the one-way sign, the R-44L. That's a very minor change, probably not even worth talking about, but the sign that we used to show in the manual had a tapered shaft. The Federal Highway Administration wrote us some time ago citing a lot of differences between our manual and their manual, and that was one of them. They said we should change that to a straight shaft, so we did. I don't have the no driving on marked shoulder sign, the R-52 circled. I probably should have. Even though these signs aren't talked about or aren't shown here, the text, section 2J5, mentions a couple other varieties of this type of sign that you can use. It mentions that the no driving on paved shoulder or just the no driving on shoulder signs, those are acceptable signs as well, even though they're not shown here. On page C-5, the cross only, this is in the lower right-hand corner, the R-72G, the cross only, and then it shows a little pedestrian symbol, and then the word signal. We decided to put that sign in, that's shown in the federal manual as well, and that's simply an alternate to the R-72B, which is in that row as well. Those are interchangeable, basically. The top of the next page, page C-6, I've circled the R-73A and the R-73F. Again, those are two signs shown in the federal manual that weren't shown in ours previously. We didn't see any good reason not to put them in there. Those signs should be used where push buttons are provided, and they should be either mounted above or incorporated into the pedestrian push button unit. Another sign on the bottom of that page, the R-85 sign, the do not stop on track sign. We used to have a sign in our manual that said no stopping on tracks. The sign in the federal manual says do not stop on tracks. I really don't know why we had the no stopping on tracks to begin with. There must have been some reason, that probably before I got here, but they didn't see any good reason not to use the federal text. That's sort of the approach they've taken in the last few years, is unless there's a good reason to be different from the Fed text, that they've decided to go with it. Unless there's a real good reason not to, I think you'll see more and more that we're conforming a lot closer to the Fed text than we used to. Okay. On page C-7 on the bottom row, I've circled the R-106. Cross traffic does not stop. This sign really should be used quite sparingly. I believe the text says it should be limited to intersections where there is a history of accidents, where motorists observe the stop sign but fail to yield to oncoming traffic. They can also be used as a temporary measure when removing multi-way stop sign installations. And those should be mounted below the stop sign. The R-109, which I have circled, and the R-109A on the top of the next page are no hitchhiking signs. They're equivalent to each other. You can use one or the other, and you should use those where there's been a lot of hitchhiking on a particular stretch of road where that's contrary to the law that exists there. Let's go to page C-9. There's a whole group of them there. Do not block driveway. I believe this is a sign shown in the federal manual. This may be used where traffic on the major roadway frequently blocks the drive. Simple as that. Fasten safety belts, state law, and the symbol sign. I believe the text says if a municipality wants to use a symbol, this is a symbol that they have to use. But then it also says that the symbol is not to be used alone, so that's sort of confusing. The last two signs there, trucks use right lane, truck lane 500 feet. From what I can tell, those are basically for truck climbing lanes, and I'm not even sure if we have any of those in Ohio. Maybe we do. We weren't sure, so that's why we put them in there. Okay, let's go on to the warning signs. W2A. I believe our text in the past may have allowed for this type of thing, where you got the side road coming out of the curve. Like I said, I think the text mentioned that before. This is really the first time we've ever shown it. The text does indicate that you shouldn't have more than two side roads shown on this curve sign, so you could put another one there, but you wouldn't want three. Let's go to page C-11. I've circled the W24A. I'm pretty sure the text previously indicated that this could be done, but we just never showed a picture of it. This is where the side roads are not quite opposite each other. That's a sign that you can use in that situation. The W32 that I have circled is real similar to the one-way sign that I talked about earlier. It's so minor that it's probably really not even worth talking about. Our sign that was previously in the manual has it shown as a tapered shaft. The feds said that we should have a straight shaft, so we decided to make that change as well. The W34A is a new sign that we put in our manual. It's a sign that appears in the federal manual, and it's just a symbol sign for a narrow bridge. It's equivalent or an alternate to the narrow bridge word legend sign. And the text indicates that these may be used on a clear two-way. A narrow bridge is sort of defined as a clear two-way road width of between 16 and 18 feet. Or you could also use this sign on a bridge having a roadway clearance less than the width of the approach pavement. So that's another situation you could use it. On page C-12, the no outlet plaque is new to our manual. We've never shown that before, but it's in the federal manual as well. I believe you're supposed to use that in combination with a street name sign at an intersection. I believe that's the way that's supposed to be used. Page C-13, the lane ends merge right, or merge left, I'm sorry, is shown in here for the first time. I believe it was actually introduced as an addendum item in revision 19. And when you use that sign, according to the text, that should be used in advance of that W60 sign, a couple signs over from it. It's to be used before that sign. On page C-14, I've circled some railroad advance warning signs where the railroad is parallel to the highway. And these are to be installed on highways that are parallel to roadways to warn the motorist making a turn that they're going to come to a railroad real quickly. The text does indicate where you have more than 100 feet between the highway and the railroad. You should use the W94, which is shown on the bottom of the next page. It's the railroad symbol sign. Where you have more than 100 feet between the highway and the railroad, you should use the W94, and you really don't need to use these, according to the text. I forgot to circle the Watch for Ice on Bridges sign. The sign we have out there now is a Watch for Ice on Bridge. This is a sign that I believe is used in Indiana. We had a Part 2 committee that looked at several issues, but this is one of them that they looked at and decided to make this change. Text indicates that this is to be placed as a general warning, and its association to a specific bridge is to be minimized. But an additional sign can be used in advance of a specific bridge when an engineering investigation and accident data shows that particular bridge does have a problem. You guys can go back and read the text. The particular section is noted below the code number. Okay, on page C-17, the horse-drawn vehicle sign, the W87. The text indicates that you may use this where such vehicles frequently use the roadway or the highway. I guess it'd mainly be used up in Amish country. The W88 beside it is a playground sign. Text indicates that it may be used in advance of a designated children's play area. It's not intended to regulate the speed of vehicles, but it's to warn them of a condition that may call for a reduction in speed. So that's a sign that's in the federal manual that we decided to put in there. On page C-18 at the bottom, there's 3 shoulder condition signs that we put in. We've always had the soft shoulder sign in the manual. That low shoulder symbol sign is not quite right. The one in the Fed manual is obviously right. I believe the bottom of the car doesn't, it's just not right. I can't explain it, but there's supposed to be a gap between the tires, I believe. And these signs are to warn of a shoulder condition that may cause vehicles to get off the pavement. And when you use them, you're supposed to put one at the beginning of the shoulder condition, and then you use additional signs at intervals throughout the length. On page C-29, I've circled a couple of guide signs there. These are really addendum items that went into the manual a couple revisions back. Maybe it was revision 19, I think it was 18. And this just sort of demonstrates what we were talking about in case you really couldn't quite understand what the text was trying to tell you. The exit panel is supposed to be over to the side that the exit ramp is on. The one on top assumes that the ramp is off to the right, and you can see that the one on the second row where the ramp goes off to the left, the exit panel has been moved over to the left. That's the way it's supposed to be done. That's what the Fed manual says, and we decided to do that as well. In addition to the new signs that were introduced, that's all I have with that handout. Another item I'd like to bring to your attention involves, it used to be called Table S1, and it used to be in the standard sign section. That's been renamed Table WS1, standing for warning signs, and it's been moved to the warning signs section. I should have provided that as a handout, I didn't. That table is to be used as an aid for determining the location of warning signs. I'm sure a lot of you have probably used it, maybe not all of you. But the table that used to be in the High manual had longer distances than that shown in the current table. Again, the table that we put in this revision is the federal table exactly. The table that used to be in there, as I said, had longer distances. So in other words, the previous table resulted in the signs being placed back further than the condition, for the condition that was being signed for than the present table does. Then another revision that was made, not related to that, involves the use of a stop sign with an intersection control beacon. Previously, the text indicated that the stop sign shall be there, I believe. It was mandatory. That's been relaxed just a little bit. Now it's a should condition. It's not quite as strong. It's still pretty strong, though. As far as revision 21 goes, you can expect to see a lot of changes made to the guide sign chapter and part 7 of the manual, the construction and maintenance operations. There's 2 committees that have been meeting on a fairly regular basis over the last few months. The committees are comprised of personnel from ODOT and some local jurisdictions, county engineers' offices, city engineers' offices, and so forth. I'm on the guide sign committee. I can't give you too much information at this time. I think one thing that you're probably going to see for sure involves the letter size on street name signs. Currently, the text indicates that the lettering on these signs should be at least 4 inches high. I'm pretty sure that the next revision will indicate that we'll change that to 6 inches. And it'll also say if uppercase and lowercase letters are used, then the uppercase would be 6 inches and the lowercase 4.5 inches. I think that's mainly to accommodate the older motorists, I'm sure a lot of you have read about that. I've also been told that revision 21 is going to incorporate a chapter on bicycle facilities, how to sign and mark bicycle paths or routes or so forth. There is a chapter in the federal manual, and it'll probably be almost word for word as that. I wouldn't be looking for revision 21 anytime in the real near future. I'd say probably you're looking at least a year. It's nowhere close to being ready to go to the printer. Once it does go to the printer, and we have one of our prisons prints the manual for us, they don't do it quite as fast as you'd get from a commercial printer. I think the last one took us almost 10 months for them to get done. So probably you can expect at least a year before that one comes out. And then at that point, I don't think you'll have any addendum items left at all up front in your manual. Anybody have any questions I can try to answer? Yeah.
You mentioned, well, we have the R52 sign, which is no driving on marked shoulder.
Uh-huh.
You said there's also a new sign available saying no driving on shoulder.
Yeah.
We have a situation in our district where we have traffic using the shoulder as turning into church.
Yeah.
And we don't want to have to go out there and paint the shoulder with no driving on marked shoulder.
Yeah, it's listed in effect as an option. Anybody else? Thanks for your attention.
Question back here.
Oh, I'm sorry.
I understand there's going to be a new federal manual in a couple of years. Do you think ODOT will adopt that manual, or do you think they'll issue a new manual since we've had 22 revisions?
My personal opinion is, and this has been looked at real closely right now, I think the overwhelming consensus is to adopt the federal manual and then issue a small supplement that might go with it that would denote differences where we want to do some things different than what's in there. There's a group of people looking at that right now. They've sent surveys out to several people in the state. maybe some people in here got them, but if I was to bet on it, I'd bet that we're going to adopt the federal manual. That's just my opinion. That's not official by any means. Anything else? Okay.
On that table WS1,
Uh-huh.
if you're changing the distances, you have time to change everything to how it's supposed to be now? Or?
No, I think that just applies to future installations, wouldn't it, Jim? I think old stuff would be grandfathered in. Is that your understanding, Jim?
Yeah, that's right. Of course, the distances in WS1 are minimum. So anything that's put up under the old table will exceed the minimums in the new table, so there's really no reason to go back and change it.
Anything else? Okay, thanks.
Table WS1 started out with the 1963 edition of the manual. It was on the committee that worked on that. And I think one of the reasons the distances are longer in that is the man that developed that table went on the assumption that a driver would slow down to 25 miles an hour before he put on the brakes. And that came up with longer distances. And the last several changes in the manual over the last 10 years or so, the changes have been made to bring the manual closer into agreement with the national manual. As Scott said, the Ohio Revised Code requires that the national manual, that the Director of Transportation adopt a manual and it shall conform to the national manual. Doesn't say it has to be exactly the same. It can't have requirements less than the national manual, but can require some extras. And that's where the differences are. Several years ago, working with the signal section of the manual, we did some comparison, word-by-word comparison of the national manual and the Ohio manual, and found some significant changes in the words with very little change in the meaning. And going back, we found out that the words in the Ohio manual were identical to some of the words in a previous change to the national manual. And we started at that time to change the wording in the Ohio manual to agree with the national manual unless there was a significant reason to make a difference. And I think that policy has been followed out with more recent changes. And I'd like to suggest one thing. When you make a change in the manual, or when you use the manual, don't just look at the pictures, but read the words. The pictures are frequently typical illustrations of the use of traffic control devices. The words, the text material describes the standards and the requirements. Some of the changes in the manual in the last several years have involved changing from the word shall to the word should. And I don't think Scott touched on the definition of the words shall, should, and may, which is an important part of the manual. If the manual says a sign shall be used under these conditions, it's a mandatory requirement. If it says should, it's a recommended requirement. It's a recommended feature. If it says may, it's permissive. It's not necessarily recommended, but it's permitted to use it. And these words are pretty important. A lot of the changes in the manual are strictly editorial, or maybe changing the rearranging of the words to make them closer to the national manual, but some of them are significant. One of the changes I noticed in Revision 20, if any of you are from rural areas where you get narrow bridge signs, I think the manual, the definition of a narrow bridge is different in Revision 20 than it was before that. Before that, I believe that defined a narrow bridge as one more than 18 feet but less than 24 feet wide. And now the definition for a narrow bridge is 16 to 18 feet wide. But when you're going to use a section of the manual, try to read it. When I enter the changes in my manual, I do them myself, and I try to identify what the changes are before I put the new pages in. My manual up here has a lot more pages than Scott's manual because I kept some of the old ones so I could see the differences. And but try to identify the differences. If you give it to somebody else and have them put into pages, there may be something significant in there that's changed and you won't know about it. Moving right along with our program, our next speaker is going to talk about sign blank materials, and this will be Jim Roth, who is a signing engineer with ODOT. He's been in that position for about 10 years. Prior to that, he was with the Bethlehem Steel Corporation in Beaumont, Texas. He's a graduate of Valparaiso University, and without further ado, I'll present Jim.
Yeah, thank you, Chuck. First thing I need to do is make one apology, and that's for the weather outside. About the second most beautiful day we've had this year, and we're stuck inside of a building. And above that, we're inside of a building with no rooms. I mean, a room with no windows. So, just to make things worse, we are being videotaped, so we have about a 10,000 candle power light here to make up for the lack of windows. Like Chuck said, my name is Jim Roth. I've been with ODOT for 10 years. I came on actually 10 years and 5 days ago, and started out as a signing engineer. Have lived through 2 reclassifications and so far 1 reorganization, and I'm still the signing engineer. So I don't know how many people at ODOT can say that. There's some advantages to that and some disadvantages, I'm sure. Basically, I'm going to talk about sign blank materials. I'm going to keep this kind of general in nature. I'm not going to get into detailed material specifications. If anybody is interested in more detailed specifications, I provided my name on a handout that I've given out, and I'll be happy to provide that if anybody's interested. Just give me a call or drop me a line or send me an email. I do have 2 handouts that I've provided. The first one says sign blank materials, 8.5 by 11, about 5 pages. And the second one is 8 standard construction drawings, which are 11 by 17. Those could be referred to as needed. What I want to do is describe what materials are currently being used by the department, why the various materials are used, what the different features are, the properties, the advantages to certain materials over other materials, and the applications for each, how we got to where we are, a history of maybe some of the things we did right, things we did wrong in the past, as far as my experiences go, and some of the things we're looking at for maybe future applications. As with Scott, I'd like to hold the questions till the end, if that's okay. If I screw something up, just jump in there and correct me at any time. First of all, the title is called Sign Blank Materials, and I'm going to use the word sign substrate principally because I think it's a little broader, maybe a little more appropriate. Substrate, the prefix sub means under, straight or stratum, layer. So the sign substrate is the underlayer. This is the material that holds the sign together. This is what the reflective sheeting is applied to. So I'm going to use the word substrate throughout. Basically, a couple things to mention at ODOT. We have 2 ways that signs get into our system. One is they're made by our sign shop in Columbus, and those are principally more of the smaller signs, principally more for maintenance purposes, knockdown replacements. There is some upgrading being done by force account. And the other method is through contracts let by the department. And those generally tend to be more of the large guide signs, freeway, expressway type signing. But there is some overlap on both of those. We have, fairly stringent requirements for the contractor that we don't always follow at our sign shop. There's a number of reasons for that. One is we like to try different things out with our own people first before we adopt them as a state standard. And we kind of look at it as a way to experiment. If something works out good, then after a number of years, contractors would be allowed to, probably allowed to do the same thing. Basically, the way I see it, there's 3 principal purposes of a sign substrate. The first one is the reflective sheeting's got to stick to it. I mean, you got to have something that the sign can stick to. The second one is it's the support, for the sign itself. It has to be able to, stay on the post. It has to be able to endure the elements out there, the wind loading, the rain, the snow, the ice. Basically, the weight of the sign itself is fairly inconsequential. It's the loading that it takes from the wind. That's the principal limiting factor. Third thing it needs to be able to do is withstand impacts from thrown objects. A lot of people run down the road, throwing their beer bottles out and what have you, and if your sign can't take that kind of a lick, it's not going to be up for very long. So those are about the three principal areas that a sign substrate needs to function for. Some of the basic things are the material that you want to use has to be readily available. And you don't want to spec out some exotic material. It has to be fairly cost effective and durable enough to withstand the environment. So I'm going to follow pretty much the handout that I gave you. The first thing we're going to talk about is materials that are currently used by ODOT, and I guess probably our bread and butter sign substrate material, which you've all seen many times, flat sheet aluminum. This is really good stuff. It's non-corrosive. Sheeting has no trouble sticking to it. Readily available, durable, can be field drilled, to match the holes in the post if you have any problems with the alignment of the holes. It's easily cut in a sign shop with just basic shear, quartering dies. It's easy to trim the sheeting on it with just a regular sheeting knife. Pretty good stuff. It is recyclable, which makes it valuable. We use various thicknesses at the department, and these are shown in the standard construction drawing, which you don't really necessarily need to refer to at this time. It's the third and fourth sheets in there. But basically, as the sign gets larger, the substrate that we require is thicker. Now, the drawings show three thicknesses, 63 mils, 80 mils, and 100 mils, and a mil being 1/1000th of an inch. So a 100 mil sign is 1/10 of an inch thick. A lot of times we call them 080 and 063. Those are just decimal fractions of an inch. Our sign shop, for inventory and stock purposes, doesn't use any of the 63 mil. We're just using the 80 and the 100. So anything that's allowed to be made with 63, we're just making it out of 80. Probably pay a few pennies more per square foot, but just easier on inventory control and what have you. The flat sheet aluminum typically used for signs up to about 20 square feet. 20 square foot sign would be a freeway or expressway speed limit sign, 48 by 60. That's getting to be about the biggest sign we make out of it. We have some speed limit signs that may be 48 by 96 that have the speed limit plus a minimum. So there you're up to 32 square feet. That works. Aluminum, flat sheet aluminum works fine for those. Occasionally we'll go wider than 48, like a 30 or 60 by 36, something along that line. But probably that's, pretty much the practical limit of aluminum. Some states use 125 mil aluminum for some of the bigger signs for a little more rigidity, which we haven't done that in Ohio, but that's another option. The alloys that we use, the best material out there that's typically used for signs is 6061. And the department in the past has always wanted the highest quality and the best material, regardless of price. And we've had to kind of back down on that recently. The 6061, it's in pretty high demand in the aircraft industry, and for that reason, the availability is a little less than some of the other alloys. The price is pretty high, so we finally decided that maybe we didn't need such an expensive alloy. We're not building an airplane here. So recently we started using 5052, which is just a little over half the price of 6061, used by a lot of other states. Basically, you couldn't tell the difference one from the other out in the field. And so, we principally use all 5052 now in our shop. We allow 6061 to be submitted as an alternate, but no one's ever done that due to the cost of it. The only minor problem that we have occasionally with 5052 is that it has a memory to it. Now, the aluminum comes off the mill and it's coiled up. And when we get the aluminum, it's been uncoiled, flattened out, and stabilized in some manner. Now, occasionally, when you blank it out into the size blank you want, some of that memory will come back and you'll get a slight bow in it. And it causes a problem if you're trying to silk screen it, especially on reverse screens. Our specification says, requires that the aluminum will stay substantially in a true plane and flat. Of course, that's open to interpretation. If we get into that's real bad, we have had some replaced. Typically, it doesn't get to that point. I mean, if we blank out a 60-inch sign and it gets too big of a bow, we can blank it into smaller signs where the bow is less apparent. So, something to be, aware of if you're going to use 5052 is, take that into consideration when you're writing your specs. Like I said earlier, the material can be recycled. It's, one of the easiest recyclable materials there is. Aluminum cans. And that also has one major disadvantage, and that's from a theft standpoint. A lot of people know that it's pretty good material, and they can, if they can find a scrap dealer who maybe is a little less scrupulous than he needs to be, they can make a lot of money in a hurry. So, there are some vandal-proof fasteners that can be used to try to eliminate that or cut down on that. Also, the material can be reclaimed, and what I mean by reclaimed is that we'll take the blanks in our shop. We got a sanding machine. We'll run them through the sanding machine, grind the old sign off, removes about maybe 2 to 4 mils of the aluminum, and then the blank goes back and can be reused for another sign. Another reason, not to use the 63 mil is, if we start with 80 mil on those smaller signs, we still got quite a bit of material left after we sand it. So, it could theoretically be sanded 2 or 3 times and reused, assuming it didn't get damaged before that. Another material that we use at the shop is plywood. Now, plywood is typically used for signs that are long, horizontal rectangles. And the reason we like plywood is it's a little more stiff than aluminum, for a sign that's wide like that. That sign's typically going to be on 2 supports. The aluminum, if you get some misalignment on your supports, the aluminum is going to tend to conform to those posts. So it's going to get a bow in it or a bend in it or a warp in it. The plywood will tend to, jerk those posts up into position to a certain extent. So we use a high-density overlay. This means it has a paper backing on both sides. It's just a typical, probably the most common sign we make, 6 foot by 1 foot. The plywood holds up pretty good. This is a marine grade plywood. I guess the main disadvantage is that it's not recyclable. You get one use out of these and that's it. We don't, try to sand them down or reuse them in any way. The thicknesses that we use, this is 1/2 inch thick. That's our most common. We use 3/4 inch thick for signs that are 10 foot long. Another common size we have is 10 feet by 18 inches, and we'll use a 3/4 inch plywood for that. Pretty cost effective, this stuff. Last time we bought it was just over $1 a square foot. That's probably gone up now since the price of wood has gone up so much lately. So. Extrude sheet. 2 of those, or the top drawing of the 11 by 17 deals with extrude sheet panels. These are basically just aluminum panels that are reinforced. They start with the same 80 mil aluminum. Stiffeners are welded on the back, and those are principally used for the larger guide signs. You can stack them up, bolt them together, make the sign any size you want. The standard panel heights are 12, 18, and 24 inches. This is a sample of, this is a 12-inch panel, 6 foot long, that was used for basically the same size sign as this one, 6 foot by 1 foot. And this will be up here if anybody wants to look at it during the break or anything. Pretty good stuff. The drawing permits fabricator to go up to 48 inches on a single panel. We typically don't get those, but I know Rocal's got a 36-inch panel here they brought that they'll show you later. Pretty good stuff. It's about $4 to $5 a square foot, so it's a little more expensive. The aluminum, flat sheet aluminum, generally runs about $1.50 a square foot, although the price is somewhat volatile and fluctuates. I guess the other sign substrate material that's commonly used is an extruded panel. An extruded panel is basically this, but it's made in one piece. Where this has the stiffeners that are spot welded to the aluminum, the extruded panel's extruded in one piece. Rocal brought some samples of that as well. I guess the main disadvantage to the extruded panel is that the maximum height is 12 inches. So you're going to have more component parts to bolt together to make your sign, more horizontal seams in it. Does that detract from the effectiveness of the sign? Probably not. Just a little bit of a cosmetic thing. We permit either one as equal alternates. Some of the other materials that we're currently looking at, we have two alloys of flat sheet aluminum that we have test installations out right now. These are shown on the second 8.5 by 11 sheet. First alloy is 3004. The second one is 3105. How do we come up with these alloys? The little number after the hyphen, 3004 H38, that's a hardness. On the 6061 T6, the T stands for temper. There's literally hundreds of alloys of aluminum, and the reason that we're looking at these two now is basically because a supplier came to us and just requested us to consider these as equivalent alloys. So we agreed, we put them out there. If there's something that somebody wants to furnish us, that's basically what drives the program. So the 3004, those signs were put up in 1994. We're planning to approve that for use. 3105 went up last September. Too early to say on that. My gut feeling is that pretty much any alloy of aluminum has a high probability of functioning. But we like to move cautiously forward. We don't have a big incentive to approve another alloy, since we have alloys that work already that are reasonably priced, and the price of these would be comparable. So we're going to go slowly forward with this. There's companies now that are selling plastic materials, and there's a lot of emphasis with recycling. They're getting the plastic out of the landfills, so there's companies that are coming up. They're trying to promote some of their recycled plastic materials for sign blanks. We've got two materials out there right now. The first one is by a company called International Plastics in Kentucky, and the second one is by Composite Technologies Corporation in Dayton, Ohio. What the International Plastics does, they get scrap plastic from the automobile industry and other places. They melt it down. This would be scrap plastic that for some reason didn't meet the specs of a car company. They melt it down and form it into panels. It's pretty good stuff. It's like a Lexan, really, is what it is. I've got a little sample of it here. The stuff is tough as nails. It's a little more expensive than the aluminum, so I expect that we'll approve this, but I don't expect that we'll ever really use much of it. just because of the cost, unless the cost comes down at some point. There's a couple drawbacks to it. It's thicker, like it comes in 160 mil and 187 mil. You know, if you're going to carry an inventory of these, you know, made into stop signs, your storage capacity has been reduced substantially from what you would have had with the aluminum. It really is, it can't be cut with our dies, with our shears. The company recommends that you buy these already pre-cut, and they mold them to size. You know, the high cost. The good thing about this material is it can be recycled. The company will buy it back from you or give you a credit on it. If you turn the stuff in, they'll just melt it down and reformulate it again. The other plastic that we have, like I said, is from Composite Technologies. Got an even smaller sample of this. We put these signs up in March of '95, about 2 years ago. Didn't really work out so well. It looks like the main problem with this material is it can't withstand beer bottles being thrown at it. I mean, all the stop signs that are parallel to the road are fine. All the signs that are perpendicular to the road do not pass with care. Some route markers. We've had 5 failures out of those, which is, you know, virtually about 50% of the signs we had out there. And all we can think is that they're just getting hit by beer bottles. So, evidenced by the number of beer bottles in the vicinity of the sign. So this won't be approved, unfortunately, unless they come up with some better formulation of it. Another material, this is on the 3rd page, that we've had some experience with at ODOT is fiberglass. Some people from ODOT here maybe remember fiberglass, probably not fondly. The history there is that, you know, like I said before, the department spec'd out 6061 aluminum as the only alloy of aluminum that would be allowed. It became hard to get, became expensive. Owens Corning has a facility over by Newark in Granville, and somebody came up with the idea, why don't we see if we can make a sign panel out of fiberglass? You know, it would have been a lot cheaper than the 6061. So it was a noble effort there. They went through a number of formulations. You know, they had to get a formula that the sheeting would stick to. They had to get a formula that wouldn't catch on fire if you tried to burn it. You know, considering the vandal, you know, people found out the signs would burn, they would probably be out there lighting them. You know, so after a number of different batches, they come up with something that looked like it had potential to work. So in 1984, ODOT decided they would go with fiberglass and offer that as an option to the 6061 aluminum. So we started making big purchases of it and putting them up out there. And it was a lot cheaper than the 6061, but it had about 6 reasons that I think it didn't really work too well. You know, starting with number 3 on the list here, a lot of guys complain about their skin being irritated by handling fiberglass all day. Bothered some people more than others. There was a little more difficult. I do have a piece here, a sample that was left over. A little more difficult trimming the sheeting on the edge due to the rough edge of it. The thickness of the panel, 135 mils, you know, a lot thicker than the aluminum. The storage capacity in the districts was a problem. But I guess the main thing was the field performance of it. You know, the panel just didn't have the ability to withstand the elements. And you've seen signs out there in the wind where the post is twisting and the sign is whipping back and forth. We were getting failure around the bolt hole. If these things were hit, you can see it's fairly flexible, but it's brittle. It won't bend like aluminum. You know, if you get an aluminum sign and you run into it with a farm implement or something, you know, that sign will bend, and usually you can pull that sign back out and get use out of it. Well, this stuff will bend to a certain point, and then it'll just snap off. So this didn't really hold up in the field, you know, the way that it should have. once we realized that we could go with, a different alloy of aluminum, we allowed 5052, and this material became even a little more expensive than the 5052, so it became a non-issue. This material is not recyclable. It's a thermal set plastic. It can't be melted down and made into another plastic item. So it can be ground up and used as an aggregate in certain things. But so we decided that we'd quit using this stuff, and nobody's complained about that decision yet that I know of. So officially, we don't use this anymore. Like I said, the last page on the handout, just my name and address, phone number. If anybody has any specific questions on sign substrates, you can talk to me at the break, or you can call me, or if you want detailed specifications, purchase specs that we use at the shop. Our spec book has brief specifications on materials that we use. So, are there any questions at this time?
Yeah, Jim, you mentioned that take that 8-0 grade aluminum and then sand it down and is that real cost effective? I mean, you're running into, time you buy the machinery and so forth to do that. Are you saving money?
Yeah, it's hard to nail down the cost in the shop. But so we do have a company on contract now that we send the material to, and they grind it down for us, and they're charging us 65 cents a square foot. The new material, and depending on where you are in the fluctuation of aluminum, probably about $1.50 right now. So you're saving about half. Now that includes, delivery and everything. So, we're getting a finished sign blank. For the $1.50, we're getting sheets of aluminum that we have to blank out. So you got to consider that we're going to have to blank these out because they've already come back, the right size. The aluminum itself can be recycled. Even if you didn't reclaim it, it has a value to it. So some other companies, I know Rocal's one, Signs and Blanks, they presented us with the idea that they will take our used signs and just give us a credit on new blanks. So we're looking into that as another option. Instead of sanding it down, they'll just melt it down or send it to a smelter, and they'll make another aluminum product out of it. So that's another option that may be virtually as cost effective as what we're doing now. And I can give you names of companies that'll do this if you're interested in what you're doing now. Yeah.
Alloy 3004 H38, it says it'll be approved for use. Will they have a cheaper price than the 5052?
No, I think they're going to be about comparable.
It's going to be comparable, so.
Yeah, I don't think we're going to save a lot of money if we go to those other two alloys. Those are, both of those alloys, my understanding is they're alloys that can be made with a high percentage of recycled material. They have trouble using recycled material to meet the 5052, so they want to open it up a little bit more, and that's the reason for those two, basically. I don't look for it to have a large savings on that. And that's why we're not in a big hurry to approve it. If we thought this was going to be like, half the price of what we're using now, maybe we try to do some accelerated testing on it, but that's the way we see it right now. Another question?
Same one.
Oh, okay. Anybody else? Okay, thank you very much.
Thank you, Jim.